All right, so in chapter 6, we're going to be talking about trig identities. So an identity is just when you have like an equation or statement that is true no matter what value you plug into it. So it means that they're always true. So like on this sheet that I gave you, right, the first ones we talked about are the reciprocal identities. So the reciprocal identities, you get that cosecant of theta. All right, what was I saying? Oh yeah, so cosecant of theta is always going to be equal to 1 over sine. Like, so everything on the sheet I gave you is always going to be true. So that means that we can like substitute these things in and rewrite like trig equations and statements. So eventually, like in the next section, we're going to learn how to like verify that identities are true using what we have here.
Paper's so old. It's decrepit.
I'm sorry that your paper is old. But like, how do you have old paper? Like,
I'll show you. This is new paper, but this is crinkled, so I cannot use it. New paper, old paper. Can you see the difference?
no.
One.
I see one.
One's dingy, exactly. One's lighter than the other. Dingy paper. It's nasty. It's yellow tip. Disgusting. But it's better to write on. Feels better on the pen. Still disgusting. Still, the texture is different. It's softer and fuzzier.
All right. You just said it was disgusting, but then you also said it's better to write on. Like, make it, do you love it or hate it?
It's yellow. It's not weird.
All right. So basically this first section goes over a lot of our like initial like fundamental identities. So for right now, we're just going to be using these like first 4 boxes on your page. So we've got the reciprocal identities, the quotient identities, Pythagorean identities, and negative angle identities. Right. So, So for right now, I just want to kind of like practice taking a statement and rewriting it in terms of another trig function. So essentially we can write everything in terms of sine and cosine in one way or another using these identities. So let's say we have cotangent of alpha plus tangent of alpha. How could we rewrite those things using sine and cosine?
Is that an A?
It's an alpha.
Okay.
Which is like an A.
That's lowercase a pretty much?
Kind of, I just do it like a little fish.
So it's A with a tail at the top.
Yes.
Okay.
Also known as the Greek letter alpha. All right, so. Okay.
This is a pretzel?
Did you call it a pretzel?
Tangent pretzel.
Okay.
Okay.
So, using identities, what are some things that cotangent and tangent are equal to?
1 over cotangent theta?
Right. But if we want to write it in terms of sine and cosine, what could we use?
Oh, sine over cosine.
Yeah, so tangent is equal to sine over cosine,
Cosine over sine.
and cotangent is equal to cosine over sine. So cotangent is the same as cosine over sine, and tangent is the same as sine over cosine. So basically you just replace pieces with other stuff that is equal to.
Okay, now what?
Right, so then we need to, we can combine it. Right, because we want to simplify it.
The cosines like cancel out?
No, we have to get a common denominator.
A common denominator of
we have-
words.
They're not words,
They're words.
they're mathematical functions.
They're words. Okay.
All right, so because in the next section when we start verifying identities, you're going to have to be able to like add stuff together and break it apart.
Just go on, I'm very confused.
All right, so I want to simplify this. I want to combine it into one fraction. So since they have two different denominators, we have to make them the same. So what do we typically do to find common denominators with numbers, Ariel? Or anybody for that matter, but. All right, so how do you find a common denominator typically? You can
Multiply.
Yeah, so we have to multiply them together basically. So our common denominator would be sine alpha times cosine of alpha.
How does that make it common at all?
Well, then we have to change our fractions to make them match that.
Times cosine of alpha?
Yes. Because then on our first fraction, we can multiply the top and bottom by cosine of alpha over cosine of alpha. All right, because it's like multiplying it by 1, but that's going to change our denominator to be this.
Or you could just move it over.
What?
Like take the sine plus cosine of that. Never mind, just go ahead.
But it's not.
That's how you do it, right?
No?
Sine alpha plus cosine alpha equals sine alpha.
It's just the two denominators put together.
Yeah,
Yeah.
but they're multiplied together. So that means you have to multiply the sine by cosine to make that have this denominator. But you have to multiply on the top and the bottom.
Okay.
So that means that would give you cosine squared, since it's cosine times cosine.
What is this?
And then on the other side, we have to take, since this denominator is cosine, we have to multiply it by sine to give it that common denominator.
Why are you multiplying by cosine on the left? Like
So
both.
then also is it sine squared on that?
Yes.
I don't know, but why is that?
All right, so let's say, Ariel, I'm adding 1/3.
No, don't. That's gonna make it worse. I'm sorry.
It's
Please don't
not.
do it.
I want to show you why I'm multiplying.
No, I understand why you're multiplying, but why are you multiplying by cosine?
Because this one already has a sine in the bottom.
Yeah.
So we need to give it a cosine as well.
Why does it need a cosine?
Because that's our common denominator. It has a sine times cosine.
How did you find out that cosine was the common denominator?
Because I have two, you just take the two things in the denominators and multiply them together.
So you cosine to one side and sine to the other side.
Yes.
Okay.
Did that help, Ariel?
Yeah.
Okay. All right, so then we have that fraction of cosine squared plus sine squared,
Why is there a plus on top?
because we're still adding them together.
But you're multiplying the ones at the bottom?
Right, we multiply the ones at the bottom to give it the common denominator, which allows us to add the top parts together.
Okay, the top part half. Okay.
Right, so then we have an identity. Yes.
Okay.
It's okay. I'm going to cut out your paper rant later, but. Or I'll leave it so Zach and Stephen can just
No, it's fine.
have a normal class. So,
Oh,
what's cosine squared plus sine squared equal to, April? It equals 1.
Wait, what?
All right, so if you look under the Pythagorean identities, right, we know that sine squared plus cosine squared equals
where'd that be?
1.
Wow, this is so helpful.
Was that a sarcastic helpful or
No,
like a
it was
joke?
not sarcastic.
Okay, I couldn't tell.
It sounded really. I thought that I was.
Oh, why did I put a
it sounded
plus
really
there?
sarcastic.
It's okay.
And then sine squiggle plus cosine squiggle equals nothing.
So then that's our answer. 1 over sine alpha times cosine alpha.
My alpha's like a little different from yours.
That's fine. It's okay.
I don't like your little alpha things. They're confusing me.
I don't like your yellow paper, but here we are. Paige, you can move up if you're having trouble seeing stuff. I see you squinting back there. All right, so again, we're going to take this one. We want to put it in terms of, I'm just talking.
Oh, okay.
All right.
Sorry.
You're fine. So we're going to take this. We want to write it all in terms of sine and cosine, and then we want to simplify it down as far as we can. So the nice thing is that our fraction on the left already has sine and cosine, right? So we don't need to change anything there at the moment. What do we need to do to tangent, though?
Tangent equals sine over cosine.
Right, tangent is equal to sine over cosine. So that gives us cosine theta over 1 plus sine theta plus sine theta over cosine theta.
And then do you have to do that special thing?
What special thing? Get the common denominator?
Mm-hmm.
Yes. So the common denominator would be what?
You multiply by cosine.
Yeah, so it would just be cosine theta times 1 plus sine theta. And I wouldn't distribute it through, I would just leave it like that.
Wait, what?
I'm multiplying my two denominators together to get this.
So why does cosine have to go first?
No, I just like to write stuff first because all right, so then what do we have to multiply our first fraction by to put a cosine in the denominator? Cosine, right? So we got to multiply it by cosine. I'm erasing that equal sign. So we have to multiply it by cosine over cosine. So that means on top, that's going to give us cosine squared. And then what do we have to multiply our other fraction by?
Why didn't you have to multiply the other one?
I haven't. That's what we're about to do.
Wait, what?
Now we have to take the other fraction and multiply it by something.
Oh, the cosine squared theta is just in the middle. Woo! Another fraction. Whoop.
Wait,
All I did, okay. Look,
wait, you can't put them on top of each other?
We can't put them together?
we haven't done the other one yet.
Okay, we multiply the other by sine.
All right, by 1 plus sine.
Yeah.
So, yeah, that's what I'm getting rid. We have to take this one and multiply it by 1 plus sine over 1 plus sine.
Okay.
Oh, that's terrible.
And then the answer is 1 plus sine squared theta.
All right, so I'm just writing it as two separate fractions right now, and then I'm going to combine it together. Or I can do it all as one, whatever you guys.
Can you do it all in one?
Yeah.
You already started doing it all
Okay.
as one.
Sorry. Yes. Deal. It's fine.
No deal.
All right, so then sine times 1 plus sine is sine theta plus sine squared theta.
Wait, how did that turn into 1? Yeah.
All right. Sine times 1 is sine. Sine times sine is sine squared.
Oh, okay, that makes way more sense.
Zach and Steven, I apologize for the chaos that is this video.
My notes look
It
awful.
just doesn't
No. Oh, yes. I thought you meant the unit circle. I'm like, what? No, but yes. Okay.
Are we past the unit circle for now?
Temporarily.
For now.
Yeah, it'll come back in this chapter still. So, we have, can we simplify anything on the top?
No.
Are you sure? We have a cosine squared and a sine squared.
Sine cubed.
No, what? No, we're adding them. If it was sine times sine squared, you could write it as sine cubed.
So, cosine squared theta, sine squared theta, would that be like 1 plus sine theta?
Yes. So we have a cosine squared and a sine squared. Sine plus cosine squared is 1.
Oh, okay. That goes back to the chart.
Yes. So we have 1 plus sine theta over cosine theta times 1 plus sine theta. All right, and then what can we cancel out?
The sine 1 plus.
Yeah, so we can, those cancel out because they're the same, which leaves us with a 1 on top and a cosine theta on the bottom.
So you just have to put a 1 on there so you know it's like a fraction.
Yeah, you have to have some kind of placeholder there.